Dear viewers, in earlier session we had seen on counting in mathematics in details. Let us continue the place value in mathematics. Do you all know what do you mean by place value? Place value of each digit in a number depends upon its place in a number. The value of a digit increases 10 times with each step to the left irrespective of the decimal point. In our decimal number system, the value of a digit depends on its place or position in the number. Each place has a value 10 times the place to its right. A number in standard form is separated into group of 3 digits using commas. Each of these groups is called a period. Now let us see about decimals. Decimals are numbers with one visible point or dot somewhere in the number. This point is called the decimal point. The digit on the left of the dot is the unit place. What kind of numbers do you most often see on price tag? You may see things like 8.50, 105.25 and so on. When you have a decimal, the place value will look like this. When you go to the left of the decimal point, you begin with the units. When you go further to the left, we know what tens, hundreds mean. But what about tens, hundreds and thousands? A tenth mean 1/10 or 1 by 10. In decimal form, we may write it as 0.1. Notice the position of the 1. It is in the 10th place. Hundreds mean 100 or 1 by 100. In decimal form, we can write it as 0.01. Now we will see about positional notation base 10. For that, we have to know the place value in powers of 10. We will take an example 4295 base 10. We can write it as 4 into 10 to the power 3, that is equal to 4000, 2 into 10 to the power 2, that is equal to 200, 9 into 10 to the power 1, which is equal to 90, and 5 into 10 to the power 0, which is equal to 5. Now we will get the value 4295. We will see another example 3.145 base 10. How can we write it this? 3 into 10 to the power 0, which is equal to 3.0. 1 into 10 to the power minus 1, which is equal to 0.1. 4 into 10 to the power minus 2, we will write it as 0.04. 5 into 10 to the power minus 3, which is equal to 0.005. So, as a base 10 number, we will write it as 3.145. Now we will see how to extend place value. Each digit in a number has a place value depending on its position. These positions can be thought of as columns labeled by powers of 10, with the powers increasing from right to left as illustrated in the following table. When reading Hindu-Arabic numerals, the value of the digit in the largest place value is read first. Thus, the number can be read it as 6392, and we think of it in columns as illustrated in the following table. When we write the numbers in the expanded form, for example, 6392 can be written as 6 into 1000 plus 3 into 100 plus 9 into 10 plus 2. Now we will see the importance of 0. The digit 0 is essential in the Hindu-Arabic system because it acts as a placeholder. In the number 702, the 0 tells us that there are no tens. Multiplying a number by 10 shifts each digit one place to the left because there is nothing in the ones place, we put 0 in that place. Because there is now nothing in ones column, we put 0 in that column. As a placeholder, the following table illustrates the process for 35 into 10, which is equal to 350. Dividing by 10 shifts the digits one step to the right and requires decimals unless the last digit in the original number is 0. The following table illustrates this process for 350 divided by 10, which is equal to 35. 351 divided by 10, which is equal to 35.1. Now we will see conventions about spacing and naming. A number with many digits can be hard to read. We cluster the digits in a groups of separate different groups by a thin space. Use place value how to gather digits into groups of 3 and to add in the remaining of larger number. We write the number shown in the place value house as 1,427,596. Converting between words and numbers and vice versa are important skills. Now we will see about system of numeration. We have already seen the way we name the numbers in Indian system and also how we write the numbers with their periods using commas. Any number of 5 digits, place value being 10,000, is read and written in the same way in both the Indian and international system of numeration. For example, this number is read as 87,654 in both the system and written in the same way, but the numbers with more than 5 digits are named and written differently. In Indian system of numeration, the first period is the ones period, that is unit family, which consists of 3 place value ones, tens and hundreds. Then the remaining period of the left of the ones period will have 2 digits each, namely thousands family, lakh family and crore family. In Indian system, the 6 digit number is written as 6,93,205. In international system, the same number is written having 2 period of 3 digits represents the 1 period in this system also, and the comma is inserted after 3 digit from the right. After that, all the periods in international system are of 3 digits only. Therefore, the above number can be read as 693,205. It is not 6 lakhs as in our Indian system, but 693,000. In international system, the first 3 digit from the ones period, the second period of the 3 digits represents thousands and the next 3 digit represents millions and the fourth period represents billions and so on. In Indian system, we have only 4 periods. Now we will see using algorithms. Children's understanding of place value improves dramatically once they start working with the formal algorithms for addition, subtraction, multiplication and division. These algorithms will be covered in other modules. When using the algorithms, there are a number of errors related to place value. For example, a common error is to enter 2 digits into a single column when carrying out the addition algorithm. Another common error is forgetting to use 0 as a place marker when students performing division. As we mentioned in the motivation, the existence of fast and efficient algorithm for arithmetic is a major advantage of the Hindu-Arabic numbers. Now we will see about Roman numerals. One of the earliest system of writing numerals is the Roman numeral system. This system is still in use in many places. For example, some faces of clocks shows hours in Roman numerals. We use Roman numerals to write a numbered list, etc. Unlike the Hindu-Arabic numeral system, Roman numeral system use 7 basic symbols to represent different numbers. The symbols are as follows: I1, V5, X10, L50, C100, D500 and M1000. Now we shall see the rules to form Roman numbers. We can form different Roman numbers using the symbols and we have to follow some rules. The first one is, if a symbol is repeated one after the other, its value is added as many times as it occurs. For example, if it has 3 I, we have to add 1 plus 1 plus 1 which is equal to 3, and if it have x and x, we have to add 10 plus 10, then we will get the answer as 20. The second rule is, the symbol I, x, c and m can be repeated up to a maximum of 3 times. For example, I1, II2, II3, x means it is 10. If it have 2x, that is called as 20. If we have 3x, it is called as 30. 1c is equal to 100, 2c is equal to 200, 3c is equal to 300, and if it is m, single m which is equal to 1000. If we have double m, we will have 2000. If we have triple m, it is called as 3000. Now coming to the third rule, V, L and D, that is 5, 50 and 500 can never be repeated in Roman numerals. The fourth rule is, if a symbol with a smaller value is written on the right of a symbol with a greater value, then its value is added to the value of the greater symbol. For example, x11 will have it as 10 plus 2 which is equal to 12. Secondly, Lx is equal to 50 plus 10 will have 60. DCCx which is equal to 500 plus 300 plus 10 which is equal to 810. The fifth rule is, if a symbol with a smaller value is written on the left of a symbol with a larger value, then its value is subtracted from the value of the greater symbol. For example, if we have IV, then it is considered as 5 minus 1 which is equal to 4. If we have IX, then we will have 10 minus 1 which is equal to 9. Another example, if you have CD which is equal to 500 minus 100 is equal to 400. Then if you have VY which is equal to 5 plus 1 which is equal to 6. If we have XI which is considered as 10 plus 1 which is equal to 11. Then the last example, DC which is equal to 500 plus 100 is equal to 600. The symbols V, L and D are never written to the left of a symbol of greater value. The disadvantage of Roman number system is there is no symbol to represent 0. Now we will see everyday use of big numbers. In this modern technological age, all of us are conversant with computers in which the use of big numbers is very common. 1 kilobyte is equal to 1000 bytes, 1 megabyte is equal to 1 lakh bytes and 1 gigabyte is equal to 1 million bytes. Kilobytes does not represent 1000 in digital arithmetic. Therefore, 1 Google is equal to 10 multiplied itself for 100 times, that is 1 followed by 100 zeros. 1 megapixel is equal to 1 million. 1 gigapixel is equal to 1 billion. Now we will see about small numbers. We know the length of 1 meter. In comparison, 1 millimeter is equal to 1 by 1000 meter which is equal to 1 by 1 lakh kilometer. You know that the size of millimeter 1 by 1 lakh of a millimeter is known as a nanometer which is equal to 1 by 1 billion of a meter. Now coming to the conclusion. In this session, we have studied about place value, Indian number system, international number system and Roman number system. In Roman numerals, we have seen about how to frame Roman numbers and what are the steps to follow in Roman numbers. Now it is time for assignment. Teachers and parents may encourage their wards by giving some assignments like the following. Firstly, you can ask the students to write some numbers and ask them to write its Indian and international system of values. Secondly, you can ask the students to write some numbers and ask them to write the values in Roman numerals.